In 4.2, we are going to start to graph some linear equations. A solution of an equation in two variables, x and y, is an ordered pair, x and y, that makes the equation true. The graph of the equation means all in x and y is a set of all points that are solutions of the equation. In this lesson, you will see that the graph of a linear equation is a line. Linear equations is a line. So use a graph to decide whether the point lies on a graph of x plus 3y equals 6 and justify your answer algebraically. So in example 1, we're going to go ahead and look at 1, 2. So when I look at the point 1, 2, I'm going to go over 1 and up 2, and I'll make my point there. Oh, my pen will work for a point. Oh, looks like I'm on the eraser. That's why I'm not getting anything. Okay, over 1, up 2, and there is my point. You can see that my linear equation does not go through that point. So if I look and I go ahead and substitute that in to see if that is in fact true, I'm going to substitute my x, 1, plus 3 times my y value is 2. Does that, in fact, equal 6? So 1 plus 3 times 2, 3 times 2 is 6, but we're adding 1, so that is not true. You can see it's very close. Our solution would be 7 equals 6 is not true, but those are close, so you can see that's why that coordinate point is close to the answer of the line. The next one says negative 3, 3. So I'm going to go over to the left, 1, 2, 3, and then up 3, 1, 2, 3. Now you can see this point, if I do a better job of this one, falls exactly on the line. So that means if I substitute those values in algebraically, that should make a true statement. So again, I would have x as negative 3. I'm going to add 3 times the value of y, which is 3, and see if that does in fact equal 6. So we'd have negative 3 plus 3 times 3 is 9, and that does equal 6. So that is a solution to the linear equation. So next, example 1, the point negative 3, 3 is on the graph of x plus 3y equals 6. But how many points does the graph have in all? The answer is that most graphs have too many points to list. So then how can you ever graph an equation? One way is to make a table or a list of a few values, plot enough solutions to recognize a pattern, and then connect the points. Even then, the graph extends without limit to the left or the smallest input and to the right of the largest input. So when you make a table of values to graph an equation, you may want to choose values for x that include negative values, 0, and positive values. This way you see how the graph behaves to the left and right of the x-axis. So we're going to use a table of values to graph the equation y plus 2 equals 3x. We're going to choose some x's. So it says rewrite the equation in the function form by solving for y. So we're going to subtract 2 from both sides. I'm on eraser again. I don't know why it keeps defaulting to eraser. Go ahead and subtract 2 from both sides, and I would end up with y equals 3x minus 2 as my equation. Now I'm going to substitute those in. I'm going to do this mentally just to be able to fit into the area I have on the screen. So if I put negative 2 in, 3 times negative 2 is going to be negative 6, minus 2 is going to give me negative 8. If I put in negative 1, I am going to get 3 times negative 1, that's going to be negative 3, minus 2, I'm going to get negative 5. 0, we like those because that cancels out our x variable, so 0 is going to be at negative 2. And if I put 1 in, 3 times 1 is 3, minus 2, that will give me 1. And one more value, 2. 3 times 2 is 6, minus 2 is 4. Now you can see they went ahead and graphed each one of those points. So we had -2, -8. We had -1, -5. 0, so I'm not going to move to the left or right, but I do need to go down, -2. Then I have 1, 1, and I have 2, 4. Now you can see there's a line is made up of an infinite number of points, so all the points on that line are also going to be solutions. We just randomly picked some pretty standard and easy to calculate negatives, positives, and a zero value. So, to graph a linear equation, you first need to put it in function form, and then you can choose some values of x and plot the points from a table of values. A line through these points is the graph of the equation. So again, our equation here is 3x plus 2y equals 1. We want to make sure that we're going to isolate y. X is going to be our inputs, y is going to be our result. So I'm going to go ahead and I'm going to subtract 3x from both sides. And I'm going to end up with 2y equals a -3x plus 1. Now I need to solve for a single y, so I'm going to divide both sides by 2. And I'm going to tell you, you might want to write this as two separate fractions. I can't simplify, so I'm going to write my coefficient as a -3/2 x, and then I'm going to add 1/2. So my equation is going to be -3/2 x plus 1/2. Now I can substitute some values in. I'm going to do -2, 0, and 2. Let's go ahead and copy that equation so I can paste it on the next page. Oops, I don't think I got my 1 in there. There, looks like I have it. Move it up here out of our way. And we're going to again do some work mentally. If I put in, I'll do the first one for you visually so you can see it. If I choose -2, I'm going to have negative, whoops, my pencil. I'm going to have that y equals -3/2. I'm going to substitute in my -2 plus 1/2. I will go ahead and -3 times times a -1 would give me 3. What did I do there when I was recopying it? -3/2, and I'm going to go ahead and I'm going to substitute in my -2. Sorry, I was having some trouble there writing. I slipped up. Alright, go back to my pen. I have a -3/2. And multiply that by a -2. And I'm going to add 1/2. So I would have 6/2 plus 1/2. And that would be 3.5. Or I could leave it as 7/2. Whichever way is easier for you to graph. So my answer for the first one is going to be 7/2. 0 I think we can do mentally because it's going to knock out my x value. So y will just be 1/2. And then if I multiply 2 by it, -3/2 times 2, and then add the 1/2, I'm going to have 5/2. Or again, you can rewrite that as 2 and 1/2 if that helps you with your graphing. In example 4, we're going to use a graph of a linear model. So they've graphed the information that they have here, and it says describe the graph in the context of a real-life situation. So we have as our x-axis the year since 1996, and the y-axis is talking about how many households have internet access. So you can see every year since 1996, the amount of households in the millions with internet access has increased steadily.